Today we are going to be talking about linear regression. Our group members are Grayson Olep, Alvin Zhang, and Grant Swayze.
What is linear regression? A line may be drawn on a scatter plot to estimate the y value given the x value. The difference of a real data point's y value from the y value predicted at the data point's x value is the residual. A least squares regression line minimizes the sum of the squares of these residuals. The bottom right shows an example of a least squares regression line. All the black points are specific xy coordinates from the data, and the red line is the least squares regression line. On an AP exam, you may be asked to describe certain aspects of a scatter plot.
The first is the strength of the correlation. If the absolute value of the R value is close to 1, there's a strong relationship, and if it's close to 0, there's a weak relationship. The second is direction. A positive R value signifies a positive association, and a negative R value signifies a negative association. Keep in mind that a positive association means that Y tends to increase as X increases, and a negative association means that Y tends to decrease as X increases. The third is the form. The form is the general pattern of the points, which can be linear, curved, exponential, or anything else. Whether or not the plot is linear can be determined from the residual plot.
To calculate the equation of the regression line, you need the standard deviation and the mean of both the x values and the y values, as well as the correlation R between x and y. These are usually provided for any given dataset on the AP exam. If the formula for the equation of the line is predicted y equals given x times the slope plus the constant, then the slope is equal to the correlation times the standard deviation of y divided by the standard deviation of x, and the constant is the mean of y minus the slope times the mean of x. On the right is the summary statistics for a sample problem. As you can see, 0.137 is the constant, 0.240 is the slope, and r squared is 0.873. You might notice that the r squared adjusted value is 0.868. We do not use that for calculating the linear regression. To use the calculator TI-84 to calculate a linear regression line from dataset, first go to Stat, Edit, and then make L1 x values and L2 the y values. Then go to Stat, Calc Linear Regression A plus Bx. Input second stat list L1 as x list, and then L2 as y list. Leave the frequency list blank, and store the regression equation in vars y1. Turn off all other equations in the y equals screen, and use zoom_stat to add the least squares regression.
Here's some AP exam tips and tricks to help you when you're taking the exam. The first one is that the calculator will give you a much more precise number than you actually need. And since there's no firm rule on rounding on the AP exam, you should decide how much to round based on the context of the problem. The second one is to treat the r squared value using the sample sentence. Blank percentage of the variation in the response variable is accounted for by the linear model relating response variable to explanatory variable. So basically, you should treat, if it asks you to interpret the r squared value, you should treat it like a fill-in-the-blank question. The last one is that the AP exam equation sheet will give you the notation B1 and B0 instead of the traditional B and A that you will see in your textbook. Here's some things to be cautious about on the AP exam. The first one is that the regression line does not have to be through 0. That means that it doesn't necessarily have to have a point at 0, 0, and that the line doesn't need to go through 0. The second one is that the pattern in the residual plot can indicate that it's not linear. So if there's a clear pattern, just know that it might not be linear. The next one is the residual equation. Understand that the residual equation is observed minus predicted, and that sometimes people switch it. The next one will be extrapolation. So using the regression line for values outside the range of x, so avoid extrapolation. After that, high slope does not mean high correlation. And the last one is influential points. So understand that a big outlier can be an influential point and affect your slope and correlation values. The three problems listed here all include linear regression. So if you need extra practice, please review these problems.